Hello everyone. So today I'm going to demo. I've added another lab on PinewoodStore, and this lab is going to be entirely focused on SQL injection. So I've added another table to the backend, and it is actually called suppliers, and it would have products related to suppliers. And this lab is concerning a SQL injection and how it is carried out. I'm going to go through some of the common SQL injections, like the classical SQL injection, and also union SQL injection. And I'm going to go over some of the vulnerabilities related to SQL injection that you might come across, but are related to what's called on OWASP top 10 terms, uh, broken access control, which is our first one, and it is also vulnerable to SQL injection. So with that being said, and as you all know it, the PinewoodStore Docker app is up now. I'm updating. I haven't added this part of the SQL injection lab to the Docker app yet. But this is just a demo. What's coming up, and I believe I'll probably add it sometime this week, maybe tomorrow or the day after tomorrow. I'll go ahead and push the change to the public Docker app, and it should be available. But yeah, this is what it looks like. Currently, it is actually running inside Eclipse as a project. And uh, I've added this supplier tab. Basically, when you click on it, it will give you another login related to supplier portal. And I've set up multiple accounts, and also let me pull up. Yeah, also tables related to suppliers, like I talked about earlier on supplier products, and does have a lot of columns. This is actually the suppliers table, but there is also a products table related to suppliers, and there it has multiple columns related, which is ID, supplier name, and we would use it in a different functionalities on the app. So let me go ahead and log in with one of the test accounts. All right, so this is one of the test accounts, and as you can see, it looks like your typical um, supplier dashboard. And now on each app functionality that I create, I try to make it as much as possible very realistic. I don't want it to be some uh, uh, kind of like a simple, boring application. That way, it will be more interesting to whoever decides to do this lab, right? And more realistic also. And I try to give it, like I said, more functionality. If you want to go back here. But you obviously when you browse away, the login expires, and you have to log in again. So I made it that way, but probably can, I guess, create a when you go to the home screen, home screen, it actually expires it. It is because of a related lab. I want it to be separated. So currently, I have one database. Although the login to the main app and the login for the suppliers app are two different tables, and that's the reason why I want it that way, is because I'm going to actually use that when I'm demoing the SQL injection. So let's go ahead and get started with a simple one first. The first one we're going to start with a simple one, the classical SQL injection, where it allows you to bypass a login and log in as some user. So for the classical SQL injection, you require some kind of information on a username that is being used, and you use that and you bypass it using by adding special characters, right? Colon, you're gonna add dash dash, which is commenting out some of the statements, right? The SQL query. So let's take a look at the source code. So this is what the source code looks like. It's basically, I left it in a way that it doesn't do any input sanitization. That way it could be exploitable. Although you might not find a whole lot of production environments set up this way, because most of the time everybody knows if you have a backend database, you need to do some kind of, especially if it accepts user input, you need to do some kind of input validation. So this is what the SQL query looks like when you log in, and it just runs this. Select from all suppliers where username is username and password and password. And we're going to use that, and we're going to supply different payloads, but we're going to use the classical payload in this instance. So with that being said, let me go ahead and get started. And the first thing I'm going to do, most SQL backend labs will have some kind of admin account, right? I'm going to try to see if I can actually log into the admin by using SQL injection. So I have burp open already. Let me go ahead and clear history. And I'm going to intercept the request, because what I'm going to do, I'm going to try to see if I can get all the traffic to burp and try to try different payloads. Now you do have, nowadays you do have a lot of extensions and tools you can run to detect any kind of SQL injection. But I don't really, from my personal preferences, I don't really like to use just an automated tool without understanding what goes on behind in the backend to allow the exploit. Because if you don't do that, if you just running the tool, honestly, you would not learn a whole lot other than run the tool. Of course, it is still a knowledge, but my recommendation is knowing the tool, what the tool does in the back end. Is that way, if you don't have access to the tool, or the most important part, most databases are not going to be the same. So the common payload might not work. You need to modify it in a certain way. So it's best to know what goes on in the back end. That way you actually modify the payload to work with whatever, if you pen testing in a professional environment, or you for your company, or maybe you're doing bug bounty programs, you can actually do a whole lot better, and also discover vulnerabilities that might be credit to your company or your bug bounty program, if you know the whole process. So most of the time, I don't like to use automated tools. Of course, there's just going to be sometimes you can't help it. This is time limitation. You just run it. And also the other problem is, especially when it comes to SQL injection, now a lot of the tools are very resource intensive. And it is actually trying to inject real payload to a backend server database. So not only resource intensive, loud. So the chances are, if you're doing bug bounty, they don't actually even allow you to do all that. You need to be very surgical if you're doing bug bounty programs. They're not going to allow you to run some kind of automated SQL injection uh, um, tool, because what could end up happening is actually you might do, instead of testing, you might take out the whole service by doing denial of service attack, because you can overwhelm the backend service, and it might start rejecting actual users. Of course, there are a lot of situations where on bug bounty programs, they don't really give you a dev access, or a dev environment. But if you're working for a company, most of the time they'll have a dev environment, and you can test it on that. In that case, it's okay to run the automated tool, because even if you take it out, I don't think it would be a major problem in a lot of companies anyway. It's still not recommended, but yeah, whenever I'm testing something like that, I like to be, especially SQL injection, I like to be very surgical, and kind of like, as much as I can, send the um, payloads one at a time or something like that. Maybe also you can slow it down sometimes. So let's go ahead and get started. A lot of SQL databases will have an admin account. So I'm gonna try with admin first. So admin, and I'm gonna try, let's say, some random password, right? Let's call it wrong password, because I'm gonna intercept it anyway. So I think interception is on, and let's go ahead and submit it. All right, it's intercepted. I'm gonna send it a repeater and just go ahead and drop it. Drop it. So usually I like to do send a repeater multiple times because you'll find out that when you're sending, you're trying different payloads, it might not work. You might need to go back. So it's always good to keep a couple of them clean. That way you can go back and change the payload. So, and also I'll show the backend. You, like I said, obviously as a bug bounty program, you might not have access to the backend log, but we are trying to learn here. So I'm going to show the backend log, and I have it open here. Let me go ahead and clear it. So the first thing, let's just try the classical, right? If you try the classical payload, what we need to do. So the query will look something like, let me go to my notes. It will look something, oh, I've actually shown you, right? It is actually here. This is a query and it's not using any input validation. When you're doing injection using the username or password, you're actually replacing the value of the username. So when you're doing that, the best way to do classical injection and get a login bypass is actually, if you know the username, the best way is to comment out everything after the username. By that, what I mean is, let's say this query, the way it runs is select all from suppliers where username is username and password is password. If you don't know the password, let's say if I were to run select from, if I were to trick the application to run instead of select all from suppliers where username is equals to username and not supply the password and still the application accepts it, then that means it's just that is the best way to bypass it, right? If I can comment that out. So the best way, some of the well-known way is actually kind of like you're going to use some or statement, make it a true statement on the side, and the end one you're going to comment that out. So the most common way to actually try to exploit this, let's go back to repeater, is going to be obviously first thing you're going to do this, and or you can use one. One is equals to one is just to show any kind of true statement. And obviously you don't want the password part to pass, right? By that what I mean is I want to comment this out because the password is, as you can see, is the wrong password. I want to trick the application into running only username is equals to admin or one is equals to one and not check the password. So I want to comment that out in SQL. You comment using dash dash. So if I were to do this, and if I were to let me go back, and like I said, we're gonna look at this just to understand what the process is, but usually you're not gonna get that. So if I send that, it's gonna be 401 rejected. And if we look in here why it is the case, as you can see here, this is the SQL it runs. It did inject it. See, select all from suppliers where username is admin or one is equals to one, but the dash dash, it does have dash dash, and this dangling or last single quote is actually causing, as you can see, a syntax error. So we got to find a way to comment that out, this single quote. That way it would be select all from suppliers where username is equals to admin or one is equals to one, and obviously dash dash, which is comment, and leave out this last quotation mark. So in that case, let's go back to the payload. That's why sometimes you just need to, when you're getting 401, you need to try different alternatives, right? Even if you can't see the backend. So I'm gonna go ahead and try to see if I can. Let me take one of the single quotes out and see if it actually that dangling or leftover single quotation mark would be added to here and it would be a perfect bypass. So I'm gonna go ahead and run it. 302. I got 302. 302 is a good thing. Whenever you get something like that, it means a redirect. It usually works. So if I go back and actually try to take a look, and as you can see here, the query runs select all from suppliers where username is equals to admin, one is equals to one, and comments out everything. And it did have a SQL error, well, let's go ahead. It's actually worked. That's the reason why it returned data. And also, even though if you can't see the backend, whenever you do injection and you get redirection, that's when you would know it's actually working. So this is a payload that we're going to use. Now I know this payload works. I'm going to go ahead and copy it. Usually this is how you need to do it on a practical environment. So go ahead and copy it and go back here, and I'm going to paste it. In this password field, I'm going to go ahead and type some random password because it could be anything, right? And just go ahead, click login. And because I don't have this turned off, let me turn this off. And I'm logged in, as you can see. So that's how you do the classical SQL injection to bypass a login. You don't see a whole lot, a lot of databases that are actually vulnerable to this kind of injection nowadays, because you know, a lot of developers are aware of what the issue is, and then and also if there is a backend, there's more than likely uh, the login screen would have some kind of input validation, so you can't really supply those special characters to trick the application into bypassing the login. All right, so this is just to show classical SQL injection. And on the next one, I'm going to go ahead and demo another SQL injection, which is the union SQL injection. And that one will be more interesting. So we will talk about that in detail in the next video. Thank you.